A very good morning to all of you. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? I hope all of you are doing great. Yeah, first of all, do comment करके बोलिए now. Is my audio videos clear to everybody? First of all, do comment करके बोलिए now. Is the audio videos clear to all of you? Tell me. Right. The 6 months roadmap to crack the gate. If you want to really crack the gate, so this master plan will help you a lot. 6 months का master plan हमने plan किया. So with this you will easily crack the gate. So you will the master concepts, practice the PYQs, revise smartly and maximize your gate score. The live workshop which is on 22nd, yesterday we had and today we have 23rd also we have. Do enroll immediately. Do enroll immediately. Link given in the description में आपको link मिलेगा. Do enroll immediately. So we are starting the new subject. We are starting. You can have a look at the microprocessor subject and then so EDC starting from 27th August onwards is starting. Right. Microprocessor and then EDC. You can utilize this opportunity before it going to expire. Now GATE 2026 an academy rankers you can find. These are the ESC 2025 ka rankers. ESC 2025 ka rankers you can have a look at. राइट सो वी डू ऑफर द 2 सब्सक्रिप्शन प्लस वाला आइकॉनिक वाला. प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस, लाइव डाउट्स, एवेल्युएटेड टेस्ट सीरीज, स्ट्रक्चर्ड कोर्सेस, पीडीएफ, लाइव टेस्ट, अनलिमिटेड एक्सेस. आइकॉनिक में एडिशनली पर्सनल कोच भी मिलेगा एज वेल एज ए physical notes also you will get additional benefit and all the plus features you will access. You can able to evaluate. Now let's see the benefits. Now these are the benefits of the plus and iconics. And you can book your time slot according to your time convenience and interact with your mentor for your proper guidance. Start your serious preparation. So we are there to help you to provide you the best guidance. Let's crack it. So चलिए आज का सेशन हम शुरू करेगा. Yeah, सबसे पहले so what we are going to discuss here. And so in this one, we are discussing about the theory network basics we have completed previously. And we will plan to discuss the network theorems will discuss. Complete network theorem problems will be discussed. After that, we start the transients and the two-port network and AC circuits will do each and every one. Chalo, let's see this thing one by one. Take the first problem. A certain network consists of two ideal voltage sources and a large number of ideal resistors. The power consumed in one of the resistors is 4 watts when either of the two sources is active, and 4 watts when other is replaced by short circuit. Now they ask him to find the power consumed by the same resistor when both are acting. So here you tell me in this case now here when only one source is present the power is given, other source is present, power is given. Now they ask you to find the power when both are present simultaneously and which is equal to what you tell me now. So that is square root of P1 plus or minus square root of P2 ka whole square. When only one source is present. So here P1 given. So that is equal to how much now? That is root 4 plus or minus root 4 whole square. How much will come P value? That is root 4 means we have a 2 plus or minus 2 whole square. Now simplify from this now. When when both are addition, we have a maximum P max, and which will be equal to 2 plus 2, 4. 4 whole square means 16. And when we have a minimum now here, P minimum, which is equal to 0 watts. So 0 watts and 16 watts. So that is option A. Now, 1 second, there is a small connection issue. Now, see the next problem. A particular resistor R dissipates a power of 4 watts when V alone active. When only voltage source is active, so that is power is given as a 4 watts. And when this I is acting alone, the power is given as a 9 watts. Now when both are acting simultaneously, they ask him to find the power. Right, so the same relation you tell me now, P, the total power P, which is equal to what we can say, tell me now here, that is square root of P1 plus or minus square root of P2 whole square. So simplify this thing here, P, that is root 4 plus or minus root 9 whole square will come to be a what, tell me now here, 2 plus or minus 3 whole square. Tell me how much will come, that is which is equal to 2 plus 3, which is equal to 5. When this is a maximum, if we ask, will come it as what, tell me now, 5 whole square will come it as a 25 watts. Minimum means how much this value will come, which is equal to 1 watt. Yes, so in this case, here actually both will come 1 watt and 25 watts. Minimum is 1 watt, maximum is 25 watts. Next. Tell me the next problem now. When Vs is 120, I1 is given 3, V2 given as 50. Power across R3 given as a 60. Now the Vs they change it to 105. Then the new values of I1, V2 and power across P3 is. Yeah, tell me now here. So initially the value of Vs is 120. Now the Vs value change it to how much now? 105. So if we see this thing here, K is what, tell me now here, how much the value changed. That means new voltage by old one, new value by old value, new value by old value. Tell me now here, new value by old value. New voltage is how much given? 105. Old value how much now? 120. So how much this value will come here? That is 5 twos 1, 5 twos 5 fours. So now we can say now 3 sevens and 3 8. That means what happens now here? K value is 7 by 8. That means excitation is multiplied by a constant K. The response in each element is also multiplied by the same constant, isn't it? So what I can right now, tell me now here. So this is initially the current is given. I1 is given as a 3. Now we can say now I1 dash. That means new current will becomes what you tell me now. I1 dash, which will be equal to K times of I1, we can say now. Excitation multiplied by some constant K. The response is also multiplied by the same constant. Right. So tell me this thing here, K value how much now? 7 by 8 into initial current is how much now? 3, which is equal to how much now? 21 by 8 amperes. Next, we have, tell me now, V2 dash is how much? So K into V2, which will come to be what, tell me now? 7 by 8 into V2 value how much now? 50. So this will come to be a, so this is 35 by 8. This is volts. Got this point now? Tell me. Now we need to get the power we need to get. Yes, so tell me the power now here. The new values of I1, V2 and the power. So look at now here, if I call this current, if I say this as I3 and this voltage is V3. Now initially power, so this P3 means what, tell me now, initial power, which is equal to V3 into I3. Okay. So that means now after that, what happens now? P3 new power, which will come to be a what, tell me now, V3 dash into what I can say now, this is I3 dash. Got it all of you? This is a new power. So will come to be what, tell me now, the new power is P3 dash. So excitation multiplied by some constant K, it will come to be what, tell me now, K into initial voltage of V3 now, tell me. And this is also equal to K into I3. So will come to be what, tell me now, P3, which will come to be what I can say now, this is K square into, will come it as V3 into I3. So this is P3, which is equal to K square into what you tell me now, V3 into I3. How much this value? This is P3 dash, which is equal to P3 only now, tell me. So how much will come the P3 dash? So the P3 dash, which will come to be a, how much now? K square. K value how much now? 7 by 8 whole square into P3. Power is how much? Initial power is 60. So it is multiplied with 60. Now tell me the answer. How much now? 7 by 8. This whole square into 60. This value 45. So we can say this as 45.9. So what's the option, you tell me? Okay, here this current is how much now? 21 by 8 will come 2.6. So this is 2.6. So this is 2.6. Now 380 by 8. This is 43.75. So this is option C. Next one. The linear network contains only resistors. If IS1 is 8, IS2 12, Vx is found to be a 80. If IS1 is minus 8, IS2 is 4, Vx is 0, then find Vx when IS1, IS2 are 20. Now, as we know that The response in any element according to SPT, the response in any element can be written as what? Tell me now. The algebraic sum of individual responses, that is K1 into what I can say now, this is IS1 plus what will be now K2 into IS2. Total response is the algebraic sum of individual responses. What are the two sources we have? IS1 and IS2. So let's find out this thing here. Vx, which is equal to K1. How much this K1 value, K2 values we need to get? So K value Vs, so they given initially they given this as a 80. So we can say now 80 equal to, this is K1 into IS1 is 8 plus K2 into IS2 value 12. So if I cancel with the 4, it will come it as a 40 equal to, will come it as a 2K1 plus 3K2. So this is one algebraic equation we develop. Next, second condition is what will be now? Vx value 0 when K1 into IS1 value given as a -8 plus K2 into IS2 value given as a 4. From this, what I can write now here, 8K1 which is equal to 4K2. So that means K1 equal to what will be now? K2 by 2 now. K1 is K2 by 2. And we'll substitute this value in the equation 1 to get the value of K1, K2 value. So it will be equal to 40 equal to, yes, so that is 2 into K1 is a K2 plus 3K2. So that means 4K2 which is equal to 40. So that is K2 value how much now? 10. And find the K1 value also. So that is K1 is equal to how much now? 5. Now we got this K1, K2 values. We can substitute in the equation, the Vx equation. K1 is how much now? 5 into IS1 plus K2 value 10 into IS2. Okay, so now they given new values, given IS1, IS2 given as 20, 20. Now I can put these values now here to get the Vx value, that is 5 into IS1 which is equal to 20 plus what will be now 10 into IS2 which is equal to 20, and simplify how much will get the Vx value. This is 100. So how much this value will come here? IS1 here will get positive values only now. So this is 100 plus this is 200. Yes, so which will come to be how much now? 300. Okay, this is 300, not 100, it's 300. Got it? All of you tell me. The same thing you got it now, everybody? Okay, here these values K1, K2 values are different. Check it, this K1, K2 values. How much we got? 8K2. So this is K1. This is 20 only. Okay, so this is will commit as what terminal K1. So this is K2 plus 3K2, which is equal to 20. When I divide this thing with the 4, will be at 20 now, not 40, isn't it? Then we'll commit as K2 4K2. 4K2 is 20, so that means K2 value how much you can see now 5. Then K1 value how much? We have a 5 by 2. Then Vx value how much we can say? K1 is a 5 by 2. 5 by 2 into IS1. 5 by 2 into IS1 plus 5 into IS2. So that is Vx, which will be given as 5 by 2 into IS1 is a 20 plus 5 into 20. So how much will come the Vx value? Tell me now. So this is 2 tenths. So 50, 100. So this is 150. 150 is correct answer. Check this thing all of you. So yeah, careful in the calculations. Next one. Superposition theorem is not applicable in the network when it is. Superposition theorem is not applicable in case of a non-linear network. Superposition theorem is valid only for in case of a linear networks only. For non-linear, superposition theorem is not applicable. Next. Superposition theorem is valid for what? Tell me now. For which case superposition theorem is valid? Only for linear networks is valid. All linear networks we can apply the SPT, superposition theorem. In a linear circuit, the superposition principle can be applied to calculate. For what we can use? For voltage and current, we can use the superposition theorem directly. Why? Because power is a non-linear, we cannot use power calculations. Next to the next one. So here the three sources they given the power due to the each one is given. They ask him to find the power when all the sources are present simultaneously. Tell me this one. Right. So this is, and what is the power you tell me now, which will be equal to plus or minus root of P1 plus or minus root of P2 plus or minus root of P3, isn't it? For this whole square. Now we need to find this power. So what will come here? This is square root of plus or minus P1. How much is value? Plus or minus root 18 plus or minus root P2 value how much? 50 and plus or minus root of P3 value how much? 98. Yeah, in this case we need to find what will be the minimum power and what will be the maximum power. We need to see it. Yeah, tell me now here when the minimum can happen and when the maximum can happen when all are positive only, no doubt. Maximum is what? Tell me now simply all are same sign, all are positive, yeah, all are negative. In that case we have a maximum first thing, right? So how much this value? Tell me this value how much will come? Root 18 plus root 50 plus root 98 whole square. This is 450. And minimum case, tell me now here, minimum case, it should be happen. What tell me now? I can say this is minus root 80, this is minus root 50, and this is plus root 98. This could be the minimum case now. So which is equal to 2, minimum case. The answer is this much. Next. The power dissipated in the 1 ohm resistor is 1 watt due to 5 volts voltage source alone and 576 due to 30 ampere current source alone. The total power absorbed in the same resistor due to both. The same analysis you tell me now, P, which is equal to square root of P1 plus or minus only 2 are there whole square. So you tell me now here, that is square root of P1 is 1 watt plus or minus P2. How much now? 576 whole square. So it should be equal to what term of 1 plus or minus, we can say 24 now, 24 whole square. So we can say the maximum is plus, that is 25 square 625. And minimum means what, Alvina? 23 square. That means how much now? 529 watts. So in this case, the answer is 625, 529. Both will come as answers. MSQ. Next, in the given circuit superposition is applied. When V2 is set to be 0, the current I2 is minus 6. When V1 is set to 0, the current I1 is plus 6. Then they ask him to find I3. So see the problem what they given now here. When V2 set to 0, that means that is shorted. So, and when V1 is set to 0 and V2 set to 0, we'll analyze now both the cases. So first case, V2 set to 0. When V2 equal to 0, that means this is shorted. Second source is shorted. When the second source is shorted, now you can tell me now. V1 is there and V2 they are set to 0. Right, so this is how much you tell me now? 3, and this is 4, and this is 6. And we have V1 is there. Now they given the current is given. I2 value given. Where is this I2? Tell me. I2 means here. This current is minus 6. This direction means this direction is plus 6 amps given. They ask him to find this current. Okay. So if this current is 6, now this voltage, which is equal to 24, mean this is positive, this is negative. Same voltage 24 volts. That means this current, how much this current is a, which is equal to 4 amperes. This current, I3 upward directions. Okay. Next. Second case, what they are saying here now, tell me now. When V1 is set to 0, tell me now, V1 is set to 0. When V1 is 0 volts, they given I1 value given. So now draw the circuit now here, but we need to get this I3 value. So then, sorry, V1 is 0. V1 is 0 here and V2 is present. And so this is 3 and this is 4 and this is 6. They given whose current is given, you see. I1 given. I1 means which direction? This direction current is given as a 6. This direction current is given as 6. This is current is 6. Mean this is positive, this is negative, that means 18. Mean this is positive, this is negative, this is 18 volts. Now we have this current is what we can say now here, this is 3 amperes. So this current is what we can say now here, 3 amperes. Yeah, you tell me now here. So they ask him to find this current. Upward direction current is 4, downward direction 3, but we need this current, we need now I2. I2 is a downward direction only now, which will be equal to minus 1 amperes. Next. Now take this next one here. Consider the following network. Determine I. When V1 is equal to 10 volts, V2 is minus 5. Okay, they given the some table form is given here, you see. This is the table form they given us like this. For the correspondingly when V1, V2 are given, the given I value given. Now they ask him to find the I value when V1, V2 is given as 10 and minus 5. As we have seen earlier, the response in any element can be written as what, tell me now? Linear combination of individual responses. That is K2 into V2. Right. They given first condition given as what, tell me now? When V1 equal to 2 volts and V2 given as 0 volts. They given this value, I value given as how much, you tell me now? 0.5 amperes. Put this values here, that is 0.5, which is equal to K1 into 2 plus what, tell me now? K2 into 0, that is 0. So from this we can get this value K1 equal to how much, you tell me now? 1 by 4. Okay. Next. Second condition they given us what, tell me now? V1. Second case they given V1 value 0 volts and V2 value they given as a 5 volts. Now they are saying this I value as minus 1 ampere. Put these values in this equation. So this is minus 1 minus 1, which is equal to what I can say now here, K1 into 0 plus what, tell me now here, K2. K2 into V2 value, which is equal to 5. So we'll come it as what, tell me now? K2, which is equal to minus 1 by 5. Isn't it? K1, K2, so you got it now? K1, K2s. Now you can put the values now here. Finally, we can write the equation. How I can write the equation? Tell me now. This is I is equal to, that is 1 by 4 into V1 minus 1 by 5 into V2. Now they given V1 is 10, V2 is minus 5. Put the values now, then I value come to be a 1 by 4 into V1 is 10 minus 1 by 5 into V2 value minus 5. So how much this value of I, you tell me now? So 10 by 4 plus 1. So will come to be a 10 by 4 means 5 by 2, 2.5. So that is 3.5 volts. Right, all of you? Next. In the given network, if Vs is equal to V naught, Vs is V naught, I is equal to 1 ampere. If the Vs is equal to V naught, then what is the value of I1? So that means they multiply, the excitation is multiplied by some constant. Excitation multiplied by some constant, we need to get it now. Okay, here they ask me I1 value, not I value. Right. Yeah, first of all, you tell me now here, when the Vs is equal to V naught, this I value given as 1 ampere. But when this is 2 V naught, not sorry, in this case, how much the Vs value, tell me now, 2 V naught. So this value also multiplied by 2. So that means this current, which will come to be a 2 amperes. This current is how much, you tell me now, 2 amperes. If this current is 2 amperes, that means this voltage, which is equal to 4 volts now. And so this current, which is 2 amperes. So that means which will be equal to 8 volts. 8 plus 4, that is 12 volts now here. So then this value, which is equal to 12 volts. That means this current, which will be equal to 4 amperes. 2 plus 4, which is equal to 6 now here. So this current is 6 amperes. This current is 6 amperes means this voltage, which is equal to 6 volts. That means this voltage, which is 18 volts. Then this current is how much now? 18 by 6, which is equal to 3 amperes. So finally this I1 value, how much, you tell me now? 3 amperes. Okay. Next one. The linear network in the figure contains resistors and dependent sources only. When Vs is equal to 10 volts, the power supplied by the voltage source is 40. What will be the power supplied by the source when Vs equal to 5 volts? So in case of a power calculations, voltage is multiplied by K, current is also multiplied by K. That's why power is multiplied by K square. And what is the K value? Tell me now. New value is a 5. Old value is a 10 now. So K value is 1 by 2. And the new power P, which will be equal to what I can say now, K square into previous power. So P dash is what I can say now, 1 by 2 whole square into P value. How much now? 40. So will come to be a 1 by 4 into 40, which will be equal to how much now? 10 watts. Right. Next. For the circuit shown in the figure, some measurements are made. Okay, these measurements are there. Measurements are missing here. So you take down these measurements here, what they has given. Right. So they given these values are Vs, Is, and IL values given. So this is 1 and 2. When Vs is a 14, this is 6 amperes. IL value 2 amperes. When this is 18 Vs, Is is 2 amperes. IL value 6 amperes. Now they are asking to develop the relation equations. Where IL is a response now, or we can write now what we can say now. The total response can be written as what, tell me now here, linear combination of individual responses. So what we can say, tell me now, K1 into Vs plus what, tell me now, K2 into Is. All of you tell me. Then we can write this as IL is equal to K1. K1, so here, so I value when this is 2, they given this as K1 into 14 plus what will be now here, K2 into Is value. How much is Is value? You can see 6. Next, second one here. So 6 is equal to what, tell me now here, K1 into 18 plus K2 into 2. So we have two equation, two unknowns. From this we can get the K1, K2 values. So get the K1 value, K1, which is equal to 0.4, and K2 value, how much you tell me now? This is minus 0.6. K2 value 0.6. So from this we can write this thing as total, this IL, we can write it as what, tell me now, 0.4 into Vs minus 0.6 into Is. This is the equation. So what's the option, you tell me now? Option D. Next one. In the circuit below, it is given that Vs value, IL value given. What values of IL and Vs will be required such that power absorbed by RL is 2.5. That means power across RL, they are saying it as a 2.5 watts they are saying. That means power across this element. So this current is what, tell me now, IL. So you tell me now, basically the power which will be equal to, that is IL square into RL, and which will be equal to 2.5, which is equal to IL square into RL value 10. So that means IL square, which will come to be a what, tell me now. So this is 2.5 by 10. Okay, this value we can say now 25 into 10 power minus 2. That's why IL value come to be how much now? 5 into 10 power minus 1. That means which is equal to 0.5 amperes. IL value we have a 0.5. Now you tell me now here. Okay, I need to have 0.5 amperes. That means how much is IL is now here? This is 500 milliamperes. I need 500 milliamperes required. For this, what should be now here? When Vs is at 20, IL value 200. But I need 500 required now. So that means what has to be done? The new Vs value, Vs dash, which will be equal to what I can say now, 500 by 200 into what, tell me now, 20. So the new values will come to be a what, tell me now, this is 50 volts. The new Vs is how much now? 50 volts and 0.5 amperes. Correct now? Next one. Now try this one. Superposition theorem is not applicable to the networks containing. Which case superposition theorem is not applicable? Tell me now. Linear case is applicable. So linear elements are what we can say now. Non-linear case is not valid. Non-linear case not valid. Dependent voltage source, current source also valid. Only for non-linear case only not valid. Next one. So see this problem. In the network, if Is is equal to I naught, okay, they given these values. Values they given. I1, okay, when Is is equal to I naught, now they are asking to find. Hmm. Earlier we have seen this type of problem. Right. When this Is is a 2 I naught, so this is multiplied by 2. The excitation is also multiplied by same constant. So that means this voltage, which I can say 2 volts now. This is 2 volts. Then this current is how much now? 2 amperes. Right. So this current is 2 amperes. This current is 2 amperes. Then this voltage, which is equal to 4 volts. Now that means this voltage, which is equal to 6 volts. Now that means this current is how much now? 6 by 6, which is 1 ampere. This is 2. That means this current is 3 amperes. They asking to find I1 only now. So I1 is how much we can say now? 3 amperes. Got it? Completed. Next one. Tell me now. The value of current I flowing through 2 ohm resistor in the given circuit equals to. What is the value of current? You tell me now. It's a parallel circuit, so voltage तो same है ना. So how much is voltage? 10 volts. And how much is voltage, which is also 10 volts. Then how much is current, you tell me now, which is equal to 10 by 2. 10 by 2, 5 amperes. Next. Yeah, this is a direct problem. You can see now here so many problems we have seen. What's the answer for it now here? The P, the total power when both are acting simultaneously, which is given as P1 plus or minus square root of P2 whole square. So the maximum power will happens when addition case. That is root P1 plus root P2 whole square, and minimum power is how much you can see now here, that is root P1 minus root P2 whole square, minimum power. Next, in the given network, if V1 V2s are 0, the values of V0 they are asking, V1 0, V2 zeros. So that means this is 0, this is also 0. These both are zeros now, 0 zeros. In those cases, they are asking to find V0. This is completely shorted path like this. Let's redraw the circuit. Otherwise, we cannot able to visualize properly. Hmm. If I redraw this part of a circuit, and then you can see this thing, these 2 and 4 are parallel. So if I consider this is the 4 amperes, this is 4 amperes. Now you can tell me now, 2 and 4 are parallel will come it as how much is value? 4 by 3. Equivalent, which is equal to what you tell me now, 4 by 3. And these two also parallel. This also will become 4 by 3 here. And here this is the resistance. Now this is 4 by 3 ohms. And this is V0. Now, so this current which is 4 amperes are going here, 4 amperes are going, 4 amperes. So this current 4 ampere has to go here. Is a shorted path now. So that means how much the current here? 0 current. 0 current means V0 value 0. Okay. Next one. Yes. Now these problems are till now we have seen the problems on the what we can say superposition theorem. Now onward the problems will consider Thevenin's theorem. Now onward these problems will consider what? Tell me now, Thevenin's theorem. Yeah, you can tell me now here. This all of you do like the session, everybody. So if you are doing like this, the complete theorems will finish. All the theorems for the problems will be finished. After that, we can start the transient part. Transient dim PYQs also will be completed. All the PYQs will do. PYQs, DPP, all the problems will do in detailed manner. Yes. Tell me. All of you do like the session and do follow the classes regularly. And we do regularly, we can daily we plan the classes. So yeah, so tomorrow also we'll plan the class. Tomorrow, day after tomorrow. 2 days we'll plan. And 26, 27 have some other works we have. Then 2 days we'll plan classes. Okay. Done? Everybody, all of you do like the session. Do like the session and share to all your friends. Done? Okay then. Yeah, that's it for today's class. And the next class will continue. The next class will do Thevenin's theorem problems. We'll see. Okay. Okay then. See you. Bye bye.